Alrighty, I'm back. I did just make another video. Funny part about it is though is I adjusted the picture, but I didn't transition it over to the actual video part, so it didn't come out right. Big mistake on my part, and even though I said I wasn't going to edit, I didn't edit. I just deleted the video because all you've seen was me, and I'm explaining things that you should be able to see, but you can't see them because I didn't transition it. So now I got to remake the video. Not a big deal. You kind of learned some things in that last video. So there's the adjustment for it, and there's a transition for it. So now you can actually see what I'm talking about this time instead of last time and stuff you couldn't see what I was talking about. So we're continuing on with operators. What are operators? Well, in math and stuff, it's pretty much the same concept, kind of. Operators are things that do such things. Operators are used to perform operations on variables and values. In this example below, so we have an example here. The plus operator adds two values together. So I'm going to go through and delete all this because this was part of what I had done in the last video that you couldn't see. Deleted that video, and now I'm going to go through and redo all this. Not a problem. So the example you probably can't see, but either way, I'm going to write it anyways because it's good exercise for me. Integer x is 100 plus 50. Okay. So first off, something I mentioned in the mistake video is that we have a couple operators here, actually. Three of them if you count this right here, the semicolon. We got a type, which is a keyword integer. Again, we're not using auto in this case because we're going to get used to what an actual integer is. The variable name is going to be x. In normal math, we know this to be as an equal sign. In C++, that is not what that symbol indicates. I did manage to pull that up before. I zoomed in on this stuff so you can see it better. I'm going to have to go back to it though, so give me just a second. Okay, back one, go up to the top here, assignments. So here's where in the cplusreference.com these operators sit. If you start off at the C++ right here, you look through this right here, you come down, eventually you find it under expressions. There's the operators right there. You probably can't see it very well, so I'll go ahead and zoom in again. Expressions, this is basically the first page you come to when you type this in and search for it. We're under expressions right here, under operators. So we're going to click on that. There's your operators right there, common operators. In this case right here, we find the equal sign that we know from math, but in this case, this is actually considered an assignment operator, not an equal sign. Basic math, yes, it's an equal sign. In C++, and C++ doesn't follow the same rules as basic math, it's actually considered an assignment operator, a simple assignment operator. Why is it considered simple? Because we also use the same assignment operator with other operators. We haven't gotten to that yet, so just keep that in mind as something you see, now you know about. But we have the A assigned to B. Think of it that way. A is assigned to B. I kind of take out the assigned part when I say this stuff. X is 100 plus 50. Okay, if we come down here and stuff, we see kind of a definition right here. Copy assignment replaces the content of an object A in their example, X in our example, with a copy of the content of B. B in their example, our example of B would be 100 plus 50. So we are assigning X to an expression 100 plus 50. If you notice when we were looking at that and stuff, we go back one, we, sorry, go back two, we see that expressions. So operators sit under expressions in the C++ reference. So this is an expression. I think in math it's considered an expression too, but I don't remember. Anyways, let's go back into that right there. Go back into assignments. We've seen the definition already for it. So we understand that this is an assignment operator, not an equal sign. And there is a big difference when it comes to C++. That's because of how this is built. We haven't gotten to that point yet, so I'm just kind of throwing it out there so you know about it. We'll get into details on that later on. C++, when learning a new language and stuff, is all about seeing it once and then trying to understand it as well, but you may not understand it right away, but you can't really go through all this and explain all this without getting into details on every little nook and cranny. If you were to think of this like cars and stuff, how fast does a car travel and stuff when it's traveling 50 mile an hour according to the speedometer? Well, according to the speedometer, you are doing 50 mile an hour. Details or nooks and crannies and stuff. When you buy brand new tires, how fast are the tires actually rotating? If the tires are so big, it may make, in one example, it may make 50 rotations before it reaches a mile. And that's just kind of an example. It's not realistic. I have no idea on the realistic part of it. Once the tire is wore down a little bit, though, it may have to increase the amount of rotations it makes. So explaining that in a concept where you have to know every little nook and cranny of the car in order to realize what everything is consistently changing to keep up the same speed is the same thing as this, except for we're not going to wear anything out this way. When it comes to writing the code and stuff, you don't really wear things out. On a car, you may do that. Same concept as anything else. You get yourself a glass of uh, something to drink in a glass and stuff. As you consume it and stuff, it changes. um, well, every time you add new code and stuff, the code may end up changing. Understanding every nook and cranny, because I mean, there's a lot of stuff we haven't explained here. We understand what this is doing. We understand what this is a little bit. I mean, we understand it's a library. We don't understand the details behind the library. For example, and I can do this. Um, you can right click on this and see a definition for this and see right here all this stuff, but doesn't make any sense to you. Probably not. It doesn't make any sense to me. So let's close that back out because we don't want to change any of that. We want this to keep working the way it's working right now. We just know that it's a library and it's meant to do outputs and inputs. It gives us the ability to output stuff to the console and input stuff as far as what a user might input. The underworkings of it, we don't know. This right here is more of just a keyword, include. We know that how it works, that it includes the library and stuff with our code. Well, this is kind of the same concept. So right here and stuff, we are literally starting to understand our little bits of code. We know that this right here is a keyword. It's also an integer. It's shortened to 3 little symbols, letters, but it means the same thing as an integer. And now we understand this right here because of previous videos that this is a variable. And how many different options are there for a variable? Infinite number, just depending on what you're using it for. We found that the best way to describe something is if we know what we're describing, use that as the description. Whether it's lumber, whether it's cost, whether it's people, whether it's grades, whatever it may be. In this case, we don't have a description for it because we're just using an example. So we're just using X because we don't know what this is going to represent. Now we're understanding what this is, an assignment operator. So it's assigning X to whatever is on the other side of the X. This is an operator. This is also an operator. This is doing the simple math. So let's go back here real quick and find that symbol. So The first place we see that symbol is right here. We do see it right here, but there's two of them together. Do we see it over here? Yes, we see it over here as well. It's right there, but there's also two of them together. So that's not what we're looking for. We're looking for it by itself. A plus B. That's what we're looking for. So it's a simple arithmetic operator. Right here it is. It just does addition. So it does the same thing in math. So this right here is the same thing for math as what it is in C++, but this is not. Right now, the way it looks, yes, it is. But you're going to find out later on and stuff that it is not. So just keep that in mind. This is also an operator as well and stuff. We haven't really looked it up, and we're not going to just yet. We know that it closes off the statement, but we do not actually know what it is. We'll get to that later on. Right now, we're just tiny steps to understanding C++ basics. So let's go back to this right here. So we see that the plus operator, which is this right here, is basically adding these two values together because these are both values. In fact, this entire expression is a single value. So are they both values? Yes, they can both be values, but in this case, they're both also one single value. An expression turned into a value. Basically, one thing has two words to it. An expression, a value. All right, so moving on. Although the plus operator is often used to add together two values, like in the example above, which is this one right here, it can also be used to add together a variable and a value, or a variable and another variable. Okay, so it has another example down here. So we're going to go ahead and keep this. We're going to make a minor edit to this so we can just copy this example into here. Sum 1, at the end it has comment here. The expression is going to equal 150. And how we get 150 is basically 100 plus 50. Then we got another integer here in the example, sum 2 is sum 1 plus integer 250. Then we got another comment over here. 400 is the result of 150. And that's kind of something else I want you to keep in mind and stuff is if you can kind of say this in your own sentence and stuff, what this is meaning. So 400 is a result of 150 plus 250, which is what this is right here. There's the 250, the sum of 1. 1 is being 150, so 150, you get that from the 100 plus 50. So you kind of use your own thoughts. Say it out loud if you need to. If you're by yourself, especially, it makes it really easy because it doesn't look like you're talking to yourself or whatnot. But yeah, if you can say it out loud and stuff and put it into a sentence and stuff, it helps because that means that if it makes sense to you, it's going to more than likely make sense to the compiler and the program and the next person, so forth, so on. We got another example down here, integer sum, variable sum 3 equals sum 2 plus sum 2. I forgot to write the 2 in there. Just to make sure, yep, okay, you can all see this. Okay, so I'm going to close that statement off right there and then put the comment there. 800, oops, 800, not 600, is a result of 400 plus 400. So what this is showing us is that we can take two values, turn it into one value, and put it into one variable. So the expression is two different values, 100 and 50. But we can add them together, turn them into an expression to make it a single value, which is 150, and that become the assignment for sum 1. So sum 1 is being assigned to 150. So, and you can see the highlighted areas, so these both are identical right here. So we're going to just take that, move this down to here, and then add another 250 to it. So we're going to take another value and add it to the variable, which is the value of 150. and that's going to replace the variable of sum2. Sum2, and this is basically going along with what it's saying right here, that we can take a variable and a value and add them together. Take two values, add them together, take a variable and a value and add it together. And the third option was take two variables and add them together. So we took two variables, sum2, which we've got right here, and we're adding them together. And this is the results of them. What would this look like printed out? Standard output, insertion, sum1. Let's go with a new line here. Yep. New line, and I'm doing my shortcut thing here again, so I don't have to retype standard output. Sum2, insertion, new line, insertion, sum3. End statement. Save. Now we got all three of them. What do they look in the terminal here, or if you were to open up a window and stuff and get to show all this? So you got 150, 400, and 800. Here's something it doesn't show though in this is, and it may show it later on. Can you do this with anything else besides this type or this keyword? I mean, obviously we know that we can change the variable. We can change the values. This is just simply showing us that we can take two values and stuff, add them together to get one variable. So that right there becomes 1. So instead of putting 100 plus 50 in here and stuff, we're just putting sum1 in there, and we got the result of what that is. Same thing with this one right here. We're taking a variable, which was the first one, adding a value to it, getting the second one. Instead of writing that into here, we're just going to put sum2 in there and get the result. And then again, with the third example and stuff, taking two variables, add them together and get that. But can this be changed to anything else? And the answer is yes. You can do this with other things too. An example of that. So we got this right here. Let's go and get rid of that. Shrink that down a little bit. Enter. In the other video and stuff where I made my mistake and stuff, yes, I did this, so I'm going to do it again. Standard string. This is just another example of how you can do this. So string A is going to be getting assigned to first. Spell it right. Okay, so we got first. Can we do the same thing with this? So, well, these are integers. This is a string. Will it work the same way? Plus string last. It doesn't look like it will. Let's see what it says here. Expression must be integral. So this is not integral. This is a string or unscoped M type. Okay, so how can we get these two to combine if we wanted them to combine? Well, it does say up here we can take two expressions or take an expression, sorry, a variable and add another integer to it. But this is not an integer. Okay, so we can't do that. But it also does say we can take two variables and add them together. So this is a variable. So can we take and create a second variable with last and add them together later? Let's see. This is just basically us experimenting with code, learning along the way. So create another string here. B is string last. Okay, so now we got our two different ones here. We've had to create one for this one for that one, kind of. These are integers, these are strings. So they're kind of the same but kind of different. But we're trying to get something like this to work with strings instead of integers. So standard string C is A plus B, end. We don't get the mistake here anymore. We don't have that error showing up anymore. So apparently this will work. Let's see what it looks like if we do that. Standard, output, insertion, C, end. Control save. Let's see if that works. Yes, it does. So we're literally able to add two strings together. We don't have a space in there, but there's no spacing in between the quotes. What if we added a space in there? Okay, so let's change C here to be a space, and we'll add another one. String with nothing in it, just a space. And let's create another string to add these three together now. String D is A plus B, no, sorry, not B, C, because we want the space in there first, plus B. Okay, so we're taking the first, adding C in there, which is a space, and then the last, because we wanted a space in between these two when it comes in down here. So now we need to change the output, because we don't want the output of C, that's just a space. We want the output of D now. We want to see what this right here ends up being. So D, control save, run the code. Now we got an error. Because we didn't end this statement right here. Mistake. Save it again. Not a big deal. Run it. And now we got the space in there. So yes, you could take strings and add them together like this. You just can't add them together in an expression because an expression requires integers or doubles or floats. Some sort of integral thing. Integral would be any of those. Integer, double, or float. We haven't really discussed integrals yet, but can you mix and match them? Play with it. Find out. Can we take this right here and substitute this for sum 3? It doesn't look like we can. Let's see. No operator plus matches these operands. So the operands and stuff, if you know what an operand is, which we haven't discussed that yet either. So this doesn't work right now, but just realize it's there. If maybe later on we learn how to do this and stuff, we can possibly do this later on. Right now, as far as what we are concerned, the best we can do with what we know so far is that we can take integers, add them together. We take the variables and add them together. We learned that up here. So now we're taking strings. We can't add strings together as we found, but we can still add variables together. So we're going to add the variables together. A plus C for the space plus B for the last gets D right there. So then we output D and we get this right here. Is there any more to this one? No, there's not. So we're moving on to the next thing. Arithmetic operators. Here is a list of them, okay? So we had it over here as well, but now we have it right here. I would definitely check because I don't know how old this is, if they've kept it up to date or not. And since C++ is changing from 23 to 26 with some updates, this may not be 100% accurate anymore. This should remain accurate. Should. Can't guarantee that. I don't know where to find out what is changing and what is not. Normally this does have the updates in it for 23, 11, 17, etc. for the different years that they change things. But for now and stuff, I mean, it's just good to know. Addition operator right there. Description adds two values together. It does say values and stuff, but we found we can do values, variables, mix and match sort of things. This depends right now. So we're just kind of learning the basics of this. The subtraction operator right there. Can we subtract these? These we can. These may be a little more difficult. Because I'm not sure how you would subtract a string from something else, but we'll get into that later. Right now, this is just the basics and stuff. If you want to play with that, you can. There's a lot to play with just with what we've learned so far. Can you multiply them? These we know we can because they work in the same math sense. These we're not too sure about. Again, play with it, figure out what you can and cannot do. The objective would be to get something to print out down here that you expect. If it doesn't come out the way you expect it to come out, then I would say it's not going to work properly. You're going to get undefined behavior and the program's not going to work properly. Here's three new ones though here at the bottom. You got modulus, increment, and decrement. Modulus, increment, and decrement. Modulus is the returns the division remainder. So when you divide two things and stuff, for example, integer x is 4. Yeah, it's 4. Integer y is 2. Simple math problem. Integer z is 4. Oops, 4, which is x, divided by 2. And then output, insertion operator, z. Go ahead and clear this out right here, save that right there, and run the program. So we're basically taking 4 and 2, dividing, I put 2 in there. We want y, not 2. Okay, so we're basically taking x, which is 4, divided by y, which is 2, to see what we get here. We got everything saved according to this right here. We run the program, we get 2. Let's change x. Let's change x to 5. Okay. Now, in our head, if we do the simple math of this and stuff, we know that 2 does not go into 5 evenly. So what is our result going to end up being? Now let's resave it and find out. Our result is still 2. Now, there's a couple different things to see here. For one, we're using integers. As you remember and stuff, integers are whole numbers that do not include decimals. So we can only have a whole number in there. Now, what if we were to change these to doubles, where a decimal is possible? So let's take this right here first. We don't need to change these two. These two are fine the way they are. But this, since this is going to end up as with a decimal point or with a remainder and stuff, we need to adjust this right here so that it can. So adding a decimal point so we know what the remainder is might give us a different outcome. Let's go ahead and save it, clear this out, run this again. We still get 2. So that didn't work. How do we see what the remainder is? Well, that's what this modular is about. So if we change this division sign to a modular sign, it will show us what the remainder is of these two values. Let's change that to the percentage sign right there, the modulus sign. Save it again, clear out the terminal, run it again. We got 1, and that is our remainder. 2 goes into 5 2 times. There is a remainder of 1. That's what modular is. It gives you what the remainder of a division is. Why would you need that in C++ or in any math? We don't know yet. It's more important to know about it than to know what it can be used for at this current time, because we are still learning just the basics. So, moving on to the next part, we got increment and decrement. Let's go ahead and see that. Because in the next example, it kind of shows some things, but this is all of it together. Let's see what this is right here. So how would we use increment and decrement? We're no longer going to be using z. Let's just go ahead and use x for the output. We can go ahead and get rid of this too because we don't need this right now. So in order to use decrement, and it shows you an example of how to use the modulus right here. Well, the same thing applies to the increment and decrement. The definition: increase the value of a variable by 1. Decrement: decrease the value variable by 1. And it shows you how to do it. So if x, which we got x right there, so we've got x set to a value. In this case, what we would do to get this to work or to see this properly, we wouldn't add this to this. We would leave this alone and create a new line right here and just put in what they have. Plus plus x. And then this would be a new statement. Okay, now they don't show this in the examples here, right here, on how to do this. Actually, it might, if you hit that try button, let's see. Yes, actually it does. So they got the exact same example. We got that right there. So it does show exactly what it does right there. So you can see what it does right there with their example. And then practice writing it just by putting it into your own and stuff. And make sure your program is going to work the same way as theirs does. I haven't saved it yet. Save it first. So if it doesn't work and stuff, you might want to save it first. Or check to make sure you have it saved. And yes, you get the same output they got. That's right there. So the same way with the minus minus, and you might check that too and stuff just to make sure that works for your program. I have found occasionally and stuff if I write something and it doesn't come out the same way, either one, I've made a mistake somewhere, or two, my editor, my compiler is not working properly, one or the other, or it could be outdated material on the website itself. But knowing which one is correct is better than not knowing. So, because if you can use it later, great. So you get the outcome of 4. If you try it right there, yes, they get the outcome of 4 as well. So we know we're doing that right. Good way to check yourself. Now they got an example down here and stuff. Go through this example real quick. There's some more down here and stuff with incrementing and decrementing examples, but this one right here and stuff, let's go through this example real quick. We're going to probably skip the second example because it looks like the second example deals with adding doubles in there. And they're not going to be any different than your regular integers are. It just got a decimal point in there. So we can do the example, yes, but um, in this case and stuff, let's just get through this first example. We'll come back uh, and we'll go through both of these examples real quick. Why not? The exercise is good for us. So integer x, I'm just basically copying what they have here in the example, 10. Integer y is 3. Oops, 3 end. And then we're going to do some outputs, standard out, insertion operator, parentheses x plus y, insertion, new line. I know I can do it with single quotes instead of double quotes. Actually, we're not going to end that, but we are going to put the comment in there. So the comment is basically saying what the result should be, 13. Now, again, I do a little bit of cheating right here, and instead of typing all that again, I just insertion again. X minus y. I wouldn't know about that at this point in time in my journey, but I know about it now because I've played with it and experimented with it enough to understand that I can kind of manipulate this a little bit and keep it working for myself. Saving you a little bit of time and stuff with less typing, but again, the exercise is good for you and stuff because it teaches you how to continuously know these things. So it's okay to be a little lazy, just don't get too lazy until you know it for sure. Oops. Insertion, new line, comments, the result should be 30. Okay, so the first one we're just adding x and y, so yes, that should be 30. The next one we're subtracting, I'm doing 10 minus 3, so result should be 3. Third one we're multiplying them, so yes, the result should be 30. And let's do the next one here for the example, which is x divided by y, insertion, new line, comment, result should be 3. You have a little bit more in here with the comment, which is integer division, which we don't really understand what that means just yet. Let's add another insertion to finish up this right here. X modulus, I had it right the first time, y, which is basically what is the remainder of x divided by y. Comment 1. Now that kind of makes more sense. Okay, so if you take x divided by y, which is 10 divided by 3, you get 3. Being that it's an integer division and stuff, you can't see the remainder. So then we show the remainder on the next line. So if you take 3 times 3, you get 9. Add the remainder, you get 10. Alright, let's keep going. Now we're going to add in another integer. Z is 5. And we're going to do that whole increment thing, increment Z, oops, and then print out insertion Z, insertion, new line, end, which we didn't end our last one. I did that last time too. Let's go back here. We need to end this. That way it doesn't give us this error right here. So we didn't end any of these right here because we wanted it to continue and stuff. But now we're at the end of that. We need that to end and stuff. That way this statement works. Okay. Now there's a comment at the end of this right here. The result should be 6. So Z started off with 5. If we increment it by 1, we should get the result of 6. Next, we're going to decrement Z, and the output insertion Z, oops, comment, this one should be 5. But why 5? If Z is already 5 when we decrement it, shouldn't that be 4? In most cases, yes. But first, after we declared Z to be 5, we first incremented it by 1. So now Z is no longer 5 at this point. Remember, the compiler goes from top to bottom. So currently it's 5. We increment it by 1. Now Z is 6. So that's where we get 6. So we're actually taking the 6 and decrement it by 1, which then we get the 5. It doesn't go from here to here and then from here to here. No, it goes from here to here and then from here to here. So let's go ahead and control and save. And let's make sure we got all that right. We should have, let's see, there's 5 here, 6, 7 outputs. 7 different results. 3, 6, 7. Yep, 13 being the first one. Yep, right there. 7 being the second one. Yep, right there. 30. Yep. And it's basic math. X plus Y equals 13. That's what the result is right here because that's what we're printing out. X minus Y, which is 7. If you do the math up here, that's what we got, and just continuously going through it. So that's the first example. The second example here, let's go ahead and get rid of all this again. Integer X again is 10. Integer Y again is 3 still. Oops, put a space in there. Okay, and then we're going to output with an insertion X divided by Y, insertion, new line, then end that statement right there with a comment. Again, we got that whole integer division thing going on right here for the comment. Result is 3, which we already know that from the previous example we just did. Okay, now we wanted to know how to get a decimal point before. How do you get that remainder that's left over into a decimal? Well, let's change both integers into doubles. So double A is 10.0. Do you actually have to have the 0.0 on there? Probably not, but we're going to put it in there anyways. We can play with it later and find out. I'm going to create another double B, which is going to be the same thing as what Y was. So this is also going to be 3. We're going to put that decimal point in there as well. And then we're going to output insertion and do the same basic math as what we did above. A divided by, don't forget to change the variables in this case. The top one's going to be the same thing as the bottom one, just different variables. Insertion, new line, comment, decimal, division. That way we know that this is decimal, the other one is integer. I didn't even spell integer right, but that's fine. Result should be 3.333 repeating. Okay, So now we got all that. Let's go ahead and save that, and let's make sure our outcomes come out properly. Make sure the code runs properly. So yes, we got 3 as for what the first one was, and we got 3.333 repeating as for what the second one is. Like I asked before, do we need the decimals in here? Let's find out. Let's take them out. Save. Run it again. No, doesn't look like it. We got the same outcome. And it is saved. So no, we don't actually have to have the decimals in there. So in this case, we got the remainder of 3.3 because this is the decimal value. Okay, if you want the actual remainder and stuff of what's left to make it 10 dividing or multiplying, then you would need the modular. This is the decimal value, the other way is the modular value. Two different ways. People that understand math might understand that a little bit better. People that don't understand math and stuff, that may be a little bit confusing. Again, I'll put this down here. So, the 0.333 is the decimal, if I can spell it right, decimal remainder, where 1 is the modulus. How do we spell that again? Yep, I have it right. Modulus remainder. Two different types right there. Decimal, modular. Kind of the same idea as decimal is the same thing as a fraction. It can be converted to a fraction. 3 remainder with the repeating and stuff is kind of hard to turn it into a fraction, but it can be done. It's not going to be precise as the decimal, but then in this case and stuff, 3 repeating and stuff over and over and over, you can't ever get precise on that and stuff because it's an infinite repetition, if I'm saying that right. But the remodular one and stuff is an exact figure. Because if you take 3 times 3, you get 9. If you add that 1 remainder to it, you get 10. Which is why this repeats, because it's, if you kind of reverse it and stuff, the math on the decimal division and stuff, it's impossible to get right back exactly to 10 again because of how many times it repeats. You would have to round it, which means you're not getting the precise figure for it. Rounding means you're taking away some of the precision. Unfortunately, computers are less precise than actually using actual math is, but we'll find that out later. So we got both examples in here now. The next part of it is the increment and decrement and stuff, which we'll get to in the next video. The idea is that you just know and stuff. Now you got the operators and stuff, the division, the subtraction and multiplication, the addition, the modulus, and the increment and decrement. You see them all. And how thorough this is in just using that. At this point in time and stuff, we're seeing a bunch of code and stuff that probably wouldn't have made sense to us when we started off in freecodecamp.org or even at the beginning of this list right here. But this is code and stuff that we wouldn't have understood at the beginning, and now we're starting to understand it. So I'm going to cut the video off right there, eat me something real quick, stretch my legs, I'll come back and start making another video, which will continue on into incrementing and decrementing. This was my journey, by the way. This is not me teaching you anything. This is how I went about learning this stuff. If this is teaching you something, great. If it's not, sorry. If it's helping, great. If you have any questions or anything like that, throw them in there. I can't promise I can answer them because, like I said, this is my journey. This is not me teaching. I do not know enough about C++ to be able to teach it. I have my sources, W3 Schools, freecodecamp.org, learncpp.com. Let me zoom this back out here real quick. I think, yeah, that works. cppreference.com, which has everything in it for C++. Uh, Channel right there was one of my sources. I was actually watching one of his videos earlier today and stuff. Apparently, he's got himself a new job, which is great. Downside to that, I guess, is the fact that he's no longer a full-time YouTuber, which is fine. He's still got all of his videos out there and stuff that help you to understand C++. Granted, they may be kind of old, maybe kind of outdated, but it still covers the basics. You're going to have to be the one that does the work, just like what I'm doing right now. You can't rely on everybody else, but you can go and look through the videos and stuff to try to figure something out that you just don't understand and it's not just coming clear, which is also might be able to help you out with it, but since I don't fully understand it yet, I'm still working on understanding myself. I have quite a bit of the basics down, but not all of them yet. So until the next video, I'm going to eat something, and I'll be right back to make another video. Thank you.